Hello everybody, and in this video I'm going to be doing more F equals ma problems. This is from 2016 and it's problem 16. So a ball is rolling from the back of a truck traveling 10 meters per second to the right. The ball is traveling horizontally at 8 meters per second to the left relative to an observer in the truck. In, in the truck should be underlined too. The ball lands on the roadway 1.25 meters below its starting level. So how far behind the truck does it land? So this is actually I would call it a relativity problem, but I know this isn't as advanced as relativity gets. But basically, to someone in a truck that's traveling 10 meters per second, anything they observe is it's shifted. It accounts for that 10 meters per second. So I won't draw a truck, but I'll draw something like this, right? So we have rightward motion, right? So 10 meters per second to the right. So to anyone in the truck, what they observe is sort of 10 meters per second to the left, or 10 meters per second to the left of what is actually happening, because they're sort of seeing things in the reverse. So if a ball is if they observe a ball moving 8 meters per second. That was a really small 8. My apologies. Um, if they observe that it's moving 8 meters per second to the left, in reality that means, or I guess not in reality, but to someone outside of the truck, it's actually moving 2 meters per second to the right. Um, and so let's say that the ball is rolling, so the ball is right here, right? So since the truck is going faster, and well, since this ball is rolling, right, it gets released at this point. So it gets released with an initial horizontal velocity of 2 meters per second to the right. And so we want to find where it will land, and we're given that the vertical displacement is 1.25 meters. That's what that second to last sentence is saying, is that the height, basically the height is 1.25 meters. And so we want to find, well, how far does it go from this point? And then, but what we really want to find is the distance from that point. So this is where the ball lands. We want to know from here, and at that time, where is the truck? Because the truck's still moving, and since this ball is going slower than the truck will be ahead of it by some distance. This is the distance we want to measure. And so really, once you boil it down to, once you find sort of the frames that you're looking at, this is just simple kinematics. So we see that this vertical displacement, right? Since the ball has no vertical or has zero initial velocity in the vertical direction, right? It's just 2 meters per second horizontally to the right. Then you start with 0 and your only acceleration is by gravity, which means that 1.25, which I'll just write as h, is equal to g over 2 times t squared, right? Um, that's just the sort of double integral of, because acceleration is just g, and we're traveling h, and since there's zero initial velocity, this is just the equation. So the F equals ma test allows us to approximate g as 10. So, and since h is 1.25, we solve that t is approximately one half seconds. Well, exactly if we're allowing g to be 10. It's exactly 1/2 seconds. So we know that in 1/2 of a second, the ball hits the ground. Now, once the ball is released from the truck, it experiences no acceleration to the right. which means it keeps its velocity of 2 meters per second to the right. And so that's just the distance it travels is just velocity times time, which is just 1 meter. The same goes for the truck, right? The truck, which was originally at this point, has traveled this distance, this total distance, in 1/2 of a second. And since it's going, uh, or did I say wait, yeah, velocity times time. So no, hold on, 2 meters per second. This is in seconds. Sorry, I was reading this as 1/s for some reason. Um, so in 1/2 of a second, the truck travels some distance, and that distance is just its velocity times time, because the velocity of the truck is constant. And so 1/2 times the truck is moving 10 meters per second, the truck moves 5 meters from the original place. So we know that the ball moves 1 meter, and the truck moves 5 meters, and so that means that the distance between them is just 4 meters, and that is the final answer. Uh, so thank you for watching, and I'll probably make more of these just on this test because I solved some pretty interesting problems here. So I hope that you watch those. Thank you.